Welcome to RK Tutorials, Solutions to Engineering Mechanics by S. Timoshenko, 5th edition. In this tutorial, we will discuss problem set to 2.5 and problem number 2.78. A bar AB hinged to the foundation at A and supported by strut CD is subjected to a horizontal 50 kilonewtons load at B, as shown in the figure. Find graphically the tensile force S in the strut and the reaction R at A. So this problem specifically he is asking to find these two values by using the graphical method. First, let's solve this problem using graphical method. Later, we will try to solve the same problem using our regular analytical method. Before going to this graphical method, let us see what are the various forces acting on this bar AB. The first force is 50 kilonewtons load. We know the magnitude is 50 kilonewtons and the direction is horizontal. We know complete details of this 50 kilonewtons. Force developed in the strut CD. It is along the bar. In what direction? We don't know the direction and we don't know the magnitude. We just know that the force in the CD is along the strut CD. We don't know the magnitude and we don't know the sense. We just know only the direction. And there is another reaction at A, and as far as the reaction at A, we don't know either direction or magnitude. Nothing is known about the reaction at A. Now, what I will do is, first I will draw the line of action of 50 kilonewtons because I know the line of action for 50 kilonewtons. This is horizontal. So this is the line of action of 50 kilonewtons. I can also draw the line of action for the force in the strut CD. Yes, I can also draw. Because this is the line of action, I can extend. These two are intersecting at a particular point. Now, the third force must passing through this point, then only the bar AB is under equilibrium because the bar AB is subjected to only three forces. So if any member subjected to three forces, all three forces must be concurrent. That means the third force, that is the reaction at A, must passing through the point, this point and the point A. Hence, the direction of reaction A I can easily identify by drawing a line passing through this point and this point. So I know the magnitude and direction of 50 kilonewtons. I know the direction of S force and I know the direction of reaction at A. Now I will construct a triangle. Now look at this. First I will draw a line of horizontal line which represents the 50 kilonewtons by taking some suitable scale. So I will take a suitable scale, that is 1 kilonewton, 10 kilonewtons is equal to 1 centimeter. So I will draw a 5 centimeters line. So this represents the complete of the 50 kilonewtons, both magnitude and direction. I know everything about 50 kilonewtons. So I have drawn a horizontal line with 5 centimeters. Now I will draw a line parallel to this which represents S passing through either this point or this point. Any point you can consider. So I am drawing a line parallel to this passing through this point, and hence I will draw a line parallel to this passing through this point. So now I will draw a line passing through this point. These two are parallel. So this gives a triangle. It is a closed triangle because I must get a closed triangle. The reason being this bar AB must be under equilibrium. Hence, I will draw one line from one end of the 5 kilonewtons. I will draw another line from the other end of the 50 kilonewtons force. Now this makes a triangle. So this line represents this S force and this line represents RA. So SA is downwards and RA is along this line and it is upwards. And what about the magnitude? By measuring this length, I can say that this length is 5.55 centimeters. That means S is equal to 5.55 into 10. Similarly, this value is the length of this line is 4.92 centimeters. Hence, I can find the value of RA because this represents RA. Hence, S is equal to 5.55 into 10, which is 55.5 newtons. And RA is equal to 49.2 into 10, which is 49.2 newtons. These two are the answers for the problem. Let us solve the same problem using our regular analytical method. That means, first of all, let us draw the free body diagram of AB. A is a hinged support. The hinged support will introduce two reactions. Let those two reactions are RAH and RAV. And the CD strut will introduce a force along the CD, and it is away from the point C. And there is a force of 50 kilonewtons. There is a force of 50 kilonewtons. Now, given that this angle is 90 degrees, hence this angle must be 90 degrees. This angle must be 90 degrees. Now, let us assume that this angle is theta. Let us assume that this angle is theta, and we know that this angle is 90. Now, S force I can resolve into two components. One is S cos theta, and another one is S sin theta. Now let us consider the equilibrium equation sigma fx is equal to 0. There are three forces acting along x-axis. Hence I can say 50 minus S sine theta minus RAH. I will consider this side is my positive. And similarly sigma Fy is equal to 0. There are two forces are acting along y-axis. By considering the upward direction is positive, I can say RAV is equal to S cos theta. Now let us take the moments about point A. Now there are all three forces will introduce the moment. All three forces. I need to find the distances first. The 50, this is the line of action of the 50 kilonewtons, and this distance, line of action to the point of moment, this distance is given 2.4. Next, this S cos theta, this is the line of action for S cos theta, and this distance, perpendicular distance, this is also given as 1.8. Next, this is the line of action for S sine theta. This is the line of action, and I required this distance. This vertical distance is required. This vertical distance is not. Then what I will do? I will consider this right angle triangle. I will consider this right angle triangle. This distance is given as 1.83 and this distance is given as 1.22. Hence, I can find this distance also. This distance square root under 1.83 square plus this height 1.22 square, which gives 2 point. So you know all the distances. And 50 kilonewtons will introduce the one side of moment, but these two will introduce in the opposite side. These two will introduce in the opposite side. Hence, I can find the moments. Now, let us take this angle is alpha. Let us take this angle is alpha. I can find sine alpha. Sine alpha is equal to the opposite side 1.83 divided by the hypotenuse that is 2.2. I can find alpha is equal to 56.29. If I know that alpha is 56.29, I can find theta because alpha plus theta is equal to 90. So theta is equal to 33.71. Now I can take the moments about point A, S sine theta into the height, that is, this is the line of action. This is the line of action. And this height is given as 1.22. So S sine theta into 1.22 plus S cos theta. This is the line of action. S cos theta into the perpendicular distance is 1.83 and that is also counterclockwise direction. Then 50 force into this is the line of action and the perpendicular distance, that is the total height, that is 2.44, but this is the clockwise, hence it is negative. And theta value is also known 33.71. I can substitute and I can simplify. Finally, I will get the S value as 55.5 kilonewtons. Next, By substituting these values into the equations 1 and 2, I can find RAH and RAV. So by substituting in second equation, I can find RAV 46.16, and by substituting S value in equation 1, I can find RAH 19.19. Hence, I can find RA is equal to root of RAH plus RAH square plus RAV square, and which gives the value of 50 kilonewton. So the same problem you can also solve using graphical method, and you can also solve using our regular analytical method.